So let's go to our sixth problem. We have here Cassandra and her friends for their cultural studies project wanted to create the teepees the Native American used, the Native Americans used. So to do so, she created a pyramid with a regular hexagonal base. If the length of the apothem, okay, so this is the apothem. Okay, the length of the apothem of the hexagonal base is equal to 24 square root of 3 inches, and the length of the side measurement of the regular hexagon base is equal to 48 inches, and the height of the pyramid is equal to 84 inches. Then what's the volume of the tent, of the teepee that the Native Americans use with a regular hexagonal base? So you see, guys, we're trying to highlight the regular hexagonal base, because what's the formula for finding the area of a regular hexagon? So that's 1/2, okay, multiplied by the apothem, multiplied by the number of sides, we can call that n, and multiplied by the side measurement itself, which we can call s. Okay, so there you go. And for this problem, we know that the area of the hexagonal figure, of the hexagonal base, so we can call that HB, is going to be equal to 1/2 multiplied by the apothem, which is equal to 24 square root of 3, multiplied by the number of sides, which is equal to 6, and which we have to multiply to the side measurement as well, which is equal to 48. So therefore, grade 8 students, this is going to give us 12 square root of 3, okay, because that cancels out, multiplied by 48 and 6. So what's 48 times 6? So that's 288. And what's 12 square root of 3 times 288? So that should give us 5,000. Okay, so the area of the hexagonal base for this one is 5,985.97 squared inches. So that's the area of the hexagonal base. But okay, we also know another formula for finding the area of hexagonal base. We can divide the hexagon that we have here into 6 equilateral triangles. So if we're going to divide that into 6 equilateral triangles, we can first find the area of one equilateral triangle. And we already know the area, the formula for finding the area of an equilateral triangle. So that's s squared, or over 4, multiplied by the square root of 3. And we know that the value of s here is equal to 48. There you go. So that's going to be 48 squared all over 4 multiplied by the square root of 3. That's just going to be the area of one triangle. Okay? So the area of one equilateral triangle, So that's going to be 48 squared divided by 4 times the square root of 3. So that's going to give us 997.66 squared inches. And how many equilateral triangles do we have? This is just for one equilateral triangle, dear grade 8 students. So for this one, how many equilateral triangles do we have? We have 6. So therefore, we can multiply this one equilateral triangle by 6. Okay, so what's 997.66 times 6? So that's just going to give us the same answer as well. The area of 6 equilateral triangles, or the area of the hexagon itself, is going to be equal to 5,985.97. And we got the same answer. We got the same base area. So these are the base areas of our given figure here, by using two formulas, or by using two strategies or two solutions, using the regular polygon formula and also using the equilateral triangle formula multiplied by 6, or the number of equilateral triangles in the regular polygon. But we haven't yet solved the problem. We need to find the volume of the entire tent itself, the entire TP. So we know that the volume, the formula for the volume of a pyramid is equal to 1/3 multiplied by the base area multiplied by the height. And since we know that the base area here has this formula, so this is the formula for the base area, it's equal to 1/2 multiplied by the apothem multiplied by the number of sides and multiplied by the side measurement itself. So therefore we can substitute this formula here and we can put it here. This is going to be 1/3 multiplied by 1/2 the apothem times the number of sides times the side measurement length of the regular polygon itself multiplied by the height. And this is going to give us a formula of 1/6 times the apothem times the number of sides times the length of the sides and times the height of the pyramid. So this is our very general formula for a pyramid that has a base area, that has a hexagonal base area. So this is the volume formula for a pyramid with a hexagonal base. And this is a very specific formula. You can derive this formula from the formula for a pyramid just by using the base area information that we have. So therefore for this one, this is going to give us 1/6 multiplied by the apothem. So what's the apothem for this one? That's still 24 square root of 3. 24 square root of 3 times the number of sides for a given figure here. So that's S and that's 6. And then times the side measurement, which is 48, multiplied by the height, which is 84. So we already know the value for this one. Okay, we've already solved for the value of 1/2. Okay. Oh, wait a minute. So that was 1/2, but for this one, this is 1/6. What we can do, we can cancel the 6 here, and then we can multiply 24 square root of 3, and then 48, and then 84, all of these three values together. So therefore, this is going to give us 24 square root of 3 times 48, and then times 84. So therefore, the volume, what's going to be the volume of our Tepee, of our Native American tent that we have here? So therefore, the volume is going to be equal to 167,607.09 cubic inches. And there you go. So the volume of the tent that we have here in cubic inches, it's a bit big because we're measuring it in cubic inches. So that's going to be 167,607 and 0.09 cubic inches. This is the volume of our given pyramid, and we've solved for the base areas in 2 ways, and we've also derived the formula for finding the volume of a pyramid with a hexagonal base. And there you go. We found the volume is 167,607.09 cubic inches, and that's how we solved it.